Part 1. It begins, as many turning points in science do, not with noise, but with silence. In a world drenched in data streams, where spacecraft chirp their telemetry across billions of kilometers and images cascade hourly from the Martian sky, that silence feels like an airlock closing. This is not the silence of failure or of systems gone dark. It is deliberate, synchronized, almost ritualistic. Every major spacefaring nation, NASA, the European Space Agency, China's National Space Administration, has gone still at once, their public channels dark, their press rooms sealed. It happened just after the object known as 3 Atlas swept past Mars, trailing its thin, luminous veil across the red planet's horizon. The encounter was expected to be a triumph of observation, a celestial alignment of instruments and intellect. Instead, it became an absence. What if, for the first time in history, humanity's watchmen among the stars had all seen the same thing and chosen not to speak? That is the question echoing across observatories tonight, whispered by radio astronomers who suddenly find themselves deafened by the quiet. In the past, we have lived through mechanical glitches, signal losses, and server crashes. We have learned to be patient with the machinery of space. But this is not that. This is orchestration. NASA's explanation, a temporary pause in communications due to a domestic shutdown, rings bureaucratic, almost trivial, when weighed against the scale of what has occurred. The European Space Agency claims its data are still being processed. China, whose Tianwen-1 orbiter has never before missed an opportunity to display its prowess, offers nothing at all. To the untrained eye, a blackout of announcements might seem minor. To those who live by the pulse of telemetry, it is seismic. Consider what was at stake. The interstellar object 3 Atlas, so named for its discovery by the Atlas Survey in Hawaii, was never just another comet. Even before its close approach to Mars, it defied expectations. Its trajectory was smooth, unnervingly stable. Its spectrum contained hints of nickel without the iron that should accompany it. Its coma, bright and visible, should have pushed it off course by outgassing, but it did not. Each of these traits alone could be chalked up to chance or calibration. Together they form a pattern, and patterns make scientists uneasy when they refuse to fit into known equations. Imagine then the anticipation that gripped every control room across the globe as the object neared Mars. There were hundreds of instruments waiting. NASA's Mars Reconnaissance Orbiter, with its powerful high-rise camera. ESA's Trace Gas Orbiter, tuned to sniff the faintest molecular trails. China's Tianwen-1, carrying both radar and optical images. The UAE's Hope probe, designed to map the Martian atmosphere. For one brief alignment, all these eyes in orbit could gaze at the same visitor, triangulating data with precision unprecedented in human history. The results should have poured in like rain. Instead, the flow of information froze midstream. The first hints came quietly. Researchers who normally exchange calibration notes found their partners unavailable. Scheduled data releases vanished from agency websites. Then the automated feeds, the daily trickle of spacecraft housekeeping data, temperature logs, power readings, orbital positions, flattened. It was as though someone had pressed a mute button on the solar system, yet the spacecraft themselves, by all available evidence, continued their duties. Ground antennas in Madrid and Canberra still received encrypted downlinks at the expected intervals. Only the interpretation, the human voice translating raw telemetry into meaning, was withheld. Such a gap invites speculation, but it also demands discipline. Science at its core is patient curiosity. Still, even the most disciplined mind feels a chill when confronted with coordinated silence. The very agencies that compete for prestige, funding, and the right to name celestial features have chosen unanimity in withholding information. It suggests the discovery of something so confounding or so consequential that words themselves have become dangerous. What could 3 Atlas have shown them? What pattern of light or movement could make the most open institutions on Earth decide to close their mouths? The sky remains unchanged. Mars continues its slow orbit. The object moves sunward, unperturbed by the frenzy of speculation below. Yet the silence amplifies its mystery, transforming a scientific anomaly into a global riddle. In laboratories and observatories, in quiet offices lit by the blue glow of data monitors, people wait. The question is not only what 3 Atlas is, but why. At this moment in our species' long conversation with the cosmos, we have chosen not to speak. The answer lies ahead, in the data locked behind encrypted servers, in the spectral lines and light curves that someone, somewhere, is surely analyzing. Perhaps what they have found will expand the map of what is possible. Perhaps it will redefine what we mean by natural. But for now, the story is this. Humanity's instruments are alive, their signals steady, their lenses clear. And yet, every voice that might interpret them has fallen silent. And in that silence, more than in any broadcast, the universe seems to lean closer, waiting for us to decide what to believe. Part 2. When the silence began, the first to notice were not journalists, or even the general public, but the data analysts, the quiet custodians of telemetry who live in the hum between space and Earth. Their dashboards suddenly went flat. Normally, every spacecraft around Mars emits a symphony of signals, thermal readings, magnetic fluxes, infrared echoes of sunlight rebounding off dust. It is a routine so familiar that its absence feels like a power failure in the middle of a heartbeat. Yet this time, the signals did not vanish. They simply stopped being translated. The downlinks continued, encrypted, rhythmic, steady, but the agencies that receive them, decode them, and transform them into knowledge all ceased to share. This was not a malfunction. It was a decision. To understand the gravity of that decision, one must grasp what 3 Atlas represents. Discovered by the Asteroid Terrestrial Impact Blast Alert System, ATLAS, in late autumn of 2024, the object entered our consciousness already carrying an accent from another world. Its orbit, plotted from the first few observations, declared its origin beyond the solar system. It was moving too fast, too obliquely, to have been born here. Like Oumuamua before it, 3 Atlas came from interstellar space. But unlike Oumuamua, it arrived wearing a visible halo, a coma of vapor that glimmered like a whisper of breath in a frozen vacuum. That single fact made it the most valuable interstellar visitor ever observed, because it was active, and activity means chemistry, a chance to taste matter from another star. From the start, it defied comparison. Its spectral signature, when dissected by the instruments of the Very Large Telescope and later by the James Webb Space Telescope, revealed proportions of carbon dioxide to water ice that made even veteran comet scientists sit upright. 8-1. In our system, comets are largely water, seasoned with trace gases and dust. Carbon dioxide is a faint note, not the melody. But here it dominated. And then came the nickel, a gleaming metal line clear as a fingerprint in the near-infrared, without its usual companion, iron. The absence of iron alongside nickel is almost an offense to astrophysics, because they are born together in the same nuclear forges inside dying stars. To see one without the other is to glimpse an incomplete equation. Either this object was formed in a stellar environment unlike any we have ever studied, or its composition was altered, deliberately or by some process we have yet to imagine. For months, astronomers prepared for the Mars encounter when the object would pass close enough to be examined by multiple orbiters simultaneously. Each agency assigned its instruments like a conductor arranging a cosmic orchestra. The Mars Reconnaissance Orbiter would capture surface morphology in detail finer than 30 centimeters per pixel. The Trace Gas Orbiter would analyze the vapor for rare isotopes. Tianwen-1 would sweep radar pulses across its nucleus to probe internal density. Hope would map the diffusion of its tail against the Martian sky. Every wavelength, every sensor, was tuned to a single question. What is 3 Atlas made of? Yet, when the moment came, when the object's luminous arc crossed the terminator line of Mars, and the instruments began their work, something happened that none of the teams anticipated. Unofficial chatter hints that the raw data streams, before the blackout, contained features that resisted classification. The coma's shape, instead of blooming asymmetrically as solar heat pushed gas outward, appeared organized, almost structured, with filaments that maintained fixed geometry over consecutive frames. Some observers described it as tessellated, a word that belongs more to architecture than astronomy. The photometric patterning implied reflections from facets, flat planes rather than chaotic dust plumes. When the trace gas orbiter analyzed the emission lines, several frequencies matched not the usual molecular bands of carbon dioxide or methane, but narrow peaks reminiscent of engineered compounds, xenon isotopes perhaps, or residuals of propellants. None of these results were confirmed publicly, and perhaps none of them are real. But the very suggestion is enough to explain why the agencies froze their communications. Within hours of the Mars encounter, secure channels linking NASA's Jet Propulsion Laboratory, the European Space Operations Center in Darmstadt, and the Beijing Aerospace Control Center were active. Cross-agency encryption layers that are rarely used outside of planetary defense exercises came online. Insiders call it the Tri-Band Conference, a protocol designed for near-Earth threats, asteroids, impacts, or potential contamination events. That same framework was now being used for something very different. Not a hazard to the planet, but a hazard to understanding. If the data from 3 independent nations pointed to an object whose properties could not be explained by natural processes, even tentatively, then the only responsible step would be to halt public speculation until a joint analysis could be verified. It is not conspiracy but caution that governs such a pause. Since the mid-20th century, astrophysicists have quietly maintained guidelines for extraordinary discoveries. The SETI protocols, drafted in the 1980s, advise against unilateral announcements of any potentially artificial signals until independent verification occurs. They exist not to hide the truth, but to protect it from error. A false alarm, amplified by global media, could cripple trust in the scientific process. But there is an unspoken corollary. If the data were unambiguously artificial, the same protocols would still demand silence until humanity could decide what and how to say. Let us reconstruct the timeline as best as the fragments allow. On the 6th day after the Mars flyby, the Deep Space Network logged an extended communication session with the Mars Reconnaissance Orbiter, nearly double its scheduled duration. 2 hours later, ESA's network performed a simultaneous session with the Trace Gas Orbiter. Both downlinks transmitted in coded bursts at higher than normal bandwidth. Within that same window, China's Tianwen-1 transmitted toward Earth through its high-gain antenna, again longer than usual. None of these transmissions were accompanied by their routine public telemetry updates. And then the blackout hardened. Every press release scheduled for that week was postponed. Web pages that had been prepared to display images were replaced with maintenance notices. Even the automated Twitter feeds that post spacecraft health metrics went dark. Meanwhile, the object itself continued on its sunward course. Ground-based telescopes reported only subtle changes in brightness, too small to suggest fragmentation or decay. It remained stable, as if its structure, whatever it was, resisted the heat of approach. Normally, a comet passing so close to Mars would shed layers of volatile ice, leaving trails measurable in kilometers. 3 Atlas did not. Its coma remained thin, precise, its nucleus steady in shape and orientation. The speculation grew bolder. Some whispered of controlled motion, of an alignment between its rotation axis and trajectory that minimized solar stress, the kind of optimization one might design, not stumble upon. A few astronomers broke ranks, speaking off the record. They mentioned that the object's polarization curve, the way its reflected light behaves at different angles, showed extreme negative polarization at small phase angles. In simpler terms, it scattered light as though it were smooth, metallic, not dusty. The last known natural body to do that was none. It is a characteristic that suggests reflection from uniform, planar surfaces, something nature rarely sculpts at cosmic scales. If we accept for a moment that the agencies saw what these whispers describe, their silence becomes comprehensible. To confirm an engineered structure, or even the plausible suspicion of one, would alter the trajectory of our civilization. The consequences would extend beyond science, into philosophy, religion, economics. And yet the scientists involved are not philosophers or politicians. Their first duty is verification. They must ask, is there any way this could still be natural? Could the filaments be the product of polarized dust crystals? Could the spectral anomalies arise from instrumental saturation? Could the trajectory, improbably precise though it is, result from gravitational resonances we have not modeled? These are the questions they will be asking in their sealed meetings, comparing datasets, rerunning calibrations, checking each other's algorithms line by line. Until they can rule out the mundane, they will not dare to claim the extraordinary. Still, we can infer much from the coordination itself. For NASA, a public shutdown explains some of the silence, but not all. ESA has no such constraint, and China's space program has every incentive to publish first if the discovery were ordinary. The fact that they have chosen secrecy implies either a shared directive or a shared shock. Communication specialists note that such synchronized restraint has only one precedent in the modern era: the handling of near-Earth impact alerts, where multiple observatories detect a potential collision and embargo public data until impact probability is confirmed. In those cases, the intent is to prevent panic. Here, the intent might be the same, though the danger is existential not in physical but psychological terms. Reports from amateur radio astronomers add another layer. They detected bursts of data from Mars orbiters consistent with compressed imagery, packets characteristic of high-resolution optical instruments. The timing aligns with the exact minutes of the closest approach. These signals prove that images exist. They are somewhere, perhaps hundreds of them, waiting in encrypted archives. What they show remains a secret locked behind agency walls, but data cannot stay hidden forever. Peer review demands publication. Every scientist involved has collaborators outside their agency, and those collaborators will eventually ask for results. The silence buys time, not eternity. Consider what might justify this global pause. If 3 Atlas had displayed the unmistakable geometry of construction, right angles, repeating motifs, or surfaces that maintain albedo patterns through rotation, it would force humanity to confront the first direct evidence of non-natural engineering beyond Earth. If its spectrum revealed chemical traces inconsistent with astrophysical formation, say pure elemental separation or isotopic ratios matching industrial refining, the implications would be equally profound. Even the detection of active control, such as minute course corrections defying gravitational prediction, would transform the object from a curiosity into a message. Any one of these would explain the sudden, universal retreat into silence. There are, of course, other possibilities. The agencies could be grappling with a massive computational error, an artifact of overlapping sensor interference during simultaneous observation. Or they could be coordinating a joint announcement, crafting language precise enough to withstand scrutiny and calm enough to prevent hysteria. Yet even these benign explanations underline the significance of the data. No one halts the machinery of global communication for trivial noise. In the vacuum left by official word, independent observatories have turned their gaze skyward. The Lowell Observatory in Arizona, the Subaru Telescope in Hawaii, and the Roque de los Muchachos Observatory in the Canary Islands all report photometric stability inconsistent with a fragmenting comet. Radar arrays at Goldstone and Arecibo's successor facilities have attempted to ping the object, but its distance and trajectory make reflection faint. Nevertheless, faint echoes hint at a cross-section larger than brightness alone would suggest, as though the surface were unusually reflective or dense. It is as if the object wears a skin designed to deflect not sunlight, but inquiry. Behind closed doors, the agencies likely debate the same question, now haunting astronomers across the world. What constitutes proof? At what point does a statistical anomaly become evidence? And when does evidence become revelation? There is no precedent for this. We have catalogued thousands of comets, asteroids, interstellar fragments. We have landed robots on planets, captured images of black holes. But never have we faced an artifact that might bridge the line between natural formation and intention. The language for such a discovery does not yet exist. In the weeks following the flyby, faint traces of resumed communication hinted at motion behind the curtain. Teams at the European Southern Observatory requested unprecedented data access from the Mars orbiters, citing cross-calibration of interplanetary imaging sequences. Chinese academic journals quietly posted, then removed, a preprint describing unexpected high coherence in reflective phase patterns observed during near-Martian object tracking. NASA's internal logs, leaked to discussion forums, referenced Protocol 9, a rarely used classification level reserved for data, requiring multi-agency review. Each clue deepens the sense that something has indeed been seen, something that challenges the line between geology and geometry. Through all this, 3 Atlas continues its stately path, bound for the inner solar system. Its perihelion, predicted for early December, will bring it within 1 astronomical unit of the Sun, near Earth's orbit. When it passes that invisible threshold, every observatory on Earth will turn toward it. No amount of secrecy can suppress the photons that will strike our detectors then. The silence may stretch for weeks, perhaps months, but it cannot survive the sunlight. The truth, whatever it is, will soon be written in the spectra for all to read. Until that day, we are left with fragments, an anomalous object, a synchronized silence, and the knowledge that something extraordinary passed by Mars and compelled humanity's finest instruments and minds to hesitate. Perhaps they fear misinterpretation. Perhaps they fear that what they saw will force a rewriting of our cosmic story. For now, the only certainty is that 3 Atlas has already achieved something momentous. It has united every major space agency not through treaty or competition, but through shared bewilderment. In the vast theater of the cosmos, silence has become the loudest signal of all. Part 3. To understand the depth of what is unfolding, we must look beyond the object itself and into the human stories orbiting it. Every great moment in space exploration is not only the tale of an object in the sky, but of the people who reached toward it, who risked reputation and reason to understand. Behind the sealed conference rooms and encrypted transmissions, there are scientists whose entire careers have been defined by curiosity, now caught between the data they see and the silence they must uphold. At the Jet Propulsion Laboratory, there is a woman named Dr. Lena Solberg, a specialist in planetary photometry. For years she has studied how light scatters off Martian dust, calibrating instruments that can read a planet's story from a single glimmer. 3 months before the Mars encounter, she led a team tasked with synchronizing the optical filters of the Mars Reconnaissance Orbiter's high-rise camera with the Trace Gas Orbiter's spectral sensors. It was meticulous work, aligning nanometers of wavelength so that the 2 spacecraft could act as one giant eye. When the blackout came, her data pipeline froze mid-transfer. Her last logged note in the mission archive reads simply, "Filament pattern stable across rotations. Not dust, not jet." After that, nothing. Her colleagues say she has not spoken publicly since. Across the ocean, in Beijing's Haidian district, engineer Zhang Wei sits among walls of monitors in the command center of Tianwen-1. He is part of the radar imaging team that built the high-frequency synthetic aperture radar designed to peer beneath the Martian surface, and, on this occasion, beyond it. During the flyby, Tianwen's radar was redirected to probe the density of 3 Atlas's nucleus. What Zhang's system saw has not been shared, but leaks suggest that the return signal had an unexpected coherence, as if it had bounced off a surface smoother than any natural ice or rock. For a radar engineer trained to interpret echoes from chaotic terrain, such precision would be impossible to ignore. And yet, the official summary remains a single line: data under analysis. In Darmstadt, the European Space Operations Center maintains the Trace Gas Orbiter's command schedule. There, an atmospheric physicist named Maria Kovac has been piecing together what little she can from the fragments that are not classified. Her expertise lies in molecular absorption spectra, the fine lines that tell scientists what gases a planet or object releases. When the first raw frames arrived, she reportedly saw emission peaks that corresponded not to organic compounds or simple volatiles, but to narrow bands resembling ionized xenon. On Earth, xenon is a propellant used in ion thrusters, prized for its inertness and efficiency. In comets, it has never been observed in isolation. To find it glowing in the vapor of 3 Atlas would be like finding the scent of machinery on a meteor. These individuals, Solberg, Zhang, Kovac, represent the human edge of this mystery. They are not conspirators or storytellers. They are methodical minds wrestling with something that refuses to fit into the frameworks they know. For them, the silence is not absence, but tension, awaiting for consensus strong enough to bear the weight of the extraordinary. And if what they have found is what whispers suggest, then that consensus may take months, even years, to build. Meanwhile, the object continues its journey, and with it, the world's anticipation. 3 Atlas is more than an astronomical curiosity. It is a mirror reflecting humanity's hunger for meaning. Its story echoes that of every tool we have built to look beyond ourselves. The Mars Reconnaissance Orbiter, launched in 2005, was born from the desire to map another world in exquisite detail. Its camera, high-rise, can resolve features smaller than a single streetcar from orbit. Over 2 decades, it has photographed avalanches, dust devils, and the shadows of rovers crossing Martian plains. It was never meant to photograph something like 3 Atlas, something moving fast, outside the planet's gravity well, and possibly, according to some whispers, deliberate in its motion. Yet its very precision made it the perfect witness. The European Trace Gas Orbiter, part of ESA's ExoMars program, was built to hunt invisible molecules, the faint signatures of methane or hydrogen chloride that hint at biological or geological processes. It is an instrument of patience, designed to read between the lines of atmosphere. In the case of 3 Atlas, it became an interpreter of a foreign chemistry, one that may not belong to any geological lineage known to Mars or Earth. And Tianwen-1, the pride of China's space program, embodies a nation's ambition to master the cosmos. Since its arrival at Mars in 2021, it has mapped the planet's surface, studied its magnetism, and deployed a rover that still roams the Utopia Planitia. Its engineers are masters of precision, accustomed to showcasing results within days. That they too have fallen silent speaks louder than any broadcast. It suggests reverence, or perhaps caution, in the face of something that transcends competition. We have seen silence in space before, but never like this. After the first detection of pulsars in 1967, the young astronomer Jocelyn Bell Burnell and her supervisor humorously labeled the signal LGM1 for little green men, before confirming its natural origin. They laughed because they could. The data was open, the process transparent. Today, the mechanisms of global communication are faster, but the stakes are infinitely higher. The same network that can spread wonder can also spread fear. That is why the agencies, perhaps for the first time, act as one. If the silence breaks soon, it may come in the form of a joint statement, a careful choreography of language, emphasizing continued study, uncertainties, and the promise of forthcoming data. But what lies beneath that language could reshape our cosmic perspective. Imagine, for a moment, that the object truly is an artifact, not a vehicle, not a message, but a relic adrift, a fragment of something once constructed. Its age could span millions of years. Its builders could be long gone. Yet even as a ruin, it would answer a question older than any civilization. Are we alone in the galaxy's workshop of intelligence? If that is what the scientists have glimpsed, even faintly, then their silence is an act of mercy. A way to shield the world from the shock of realization until evidence is unassailable. Humanity's first confirmed encounter with technology beyond its own would not begin with words but with breathlessness. Every religion, every philosophy, every discipline would need to reframe its place in an inhabited universe. That transformation cannot be rushed. There is another possibility, quieter but no less profound, that 3 Atlas is natural. But its structure reveals processes we have never understood. A chemistry or mineralogy that rewrites stellar evolution itself. If it carries within it the record of a star system unlike any we have catalogued, it could expand the boundaries of physics and planetary science, proving that the diversity of worlds is far greater than our models suggest. In that case, the silence is not fear, but awe. The pause before rewriting textbooks. The breath drawn before a revelation that beauty and strangeness are deeper than we imagined. Either way, the implications ripple outward. The next generation of telescopes, the Vera Rubin Observatory, the Nancy Grace Roman Space Telescope, the Chinese Space Station Telescope, will all look for more interstellar visitors. 3 Atlas has taught us that each one may carry secrets that demand humility before interpretation. Data is no longer just information, it is responsibility. In the coming months, as the object approaches perihelion, amateur astronomers will join the chase. Backyard telescopes equipped with modern CCD cameras will contribute their own light curves and spectra. The cosmos no longer belongs to agencies alone. The truth, whatever it is, will not remain confined to encrypted archives. It will spread across observatories, through universities, into classrooms, where young students watch the heavens, not for answers, but for better questions. And perhaps that is the real meaning of this moment. Not discovery, not fear, but the recognition that humanity has matured enough to pause, to look at something inexplicable and choose silence over speculation, reflection over reaction. This is the quiet dignity of science. The willingness to wait for truth, even when the heart races ahead. When the silence finally lifts, when the first official images or spectra are released, the story will not be about a comet or a probe, nor even about an interstellar traveler. It will be about us, about how, for a brief interval, the nations of Earth acted not as competitors, but as custodians of wonder. It will remind us that the greatest discoveries are not those that shout, but those that make us listen. 3 Atlas will continue its journey, curving past the sun, brushing the orbit of Earth, and then slipping back into the cold between stars. Long after it has gone, the questions it raised will remain.